Hello everyone, welcome back to another video where we continue building our game in LÖVE 2D. So I'm pretty excited for this video because we're going to essentially scale up what we implemented in our last video. Essentially we're going to turn more of our game entities or game objects into objects using classes. So if you remember last time, let me pull that up, we made our trees a class, or we created a tree class, and then we gave, we created specific behavior for our trees. There's a couple things that we fixed when we did this. Essentially, we made all of the trees have their own timer and their own animations, which essentially made it so that if you were to burn a tree and then second tree, they would run on separate timers, and then they would disappear at a different point in time. They would run their own animation, and it kind of made the whole game just better for our trees. So what we're going to do today is we're going to essentially do the same thing with our Yeti and our skier. And one of the things that I've kind of been meaning to fix is, if you see here, our Yeti is going to eat the first skier, but the second skier is just going to disappear. And that's because, similar to the tree, the skiers and the Yeti eating the skiers are running on the same timers and on the same collision detection. So we're going to fix that. Perfect. All right, so let's get cooking. All right, so let me pull up the code. So we're going to do a couple things, and then you'll see, like today, because we're just scaling up like what we did last time, most of our programming is actually just going to be copy pasting. So what I'm going to do here first, I'm going to create a new file. I'm going to call it dependencies. Dependencies.lua. And we're going to move all of our global variables into that file. And by global variables, I just mean variables that are called in main, but also in other scripts. We're also going to move our sprites and drawings and images and all of that into dependencies. So now that we've done that, the first thing that we'll need to do is we'll need to make sure that we source that code back into main. So I'm going to call it require, and I'm going to call lib/dependencies. Just like that. Perfect. So we're going to first work on our Yeti class. So I'm going to create a Yeti file. I'm going to call it yeti.lua. And what we're going to do is we're actually going to copy paste the entire tree class into our Yeti script. Just like that. And then, like I said, just a lot of copy pasting. We're just going to essentially configure it to the Yeti object. So whenever we see tree, we're just going to change it to Yeti. Actually, the tree removal, so this is a function that's unique to trees, essentially. Only the trees are getting removed and have the burning animation. So we're going to delete that. We don't need it for a Yeti class or Yeti objects. And then we're going to finish putting our Yetis. We're going to update the texture to a Yeti texture, and then we're going to set the user data to the Yeti. And that's so that essentially when we do a collisions callback, we can recognize that our Yeti object is a Yeti. The other thing that we're going to update, the X value and the Y value are going to be in the middle of the screen. So we're going to make our X window width divided by 2, and then we're going to do window height divided by 2 for Y. And finally, well, actually two more things. We're going to change our physics object from a static object, like our trees, which don't move, to a dynamic object. And finally, make our rectangle shape for our Yeti a 60 by 60 square. Cool. So now what we can do is, if we go into main, we'll need to bring in our Yeti animations. So let me get the Yeti animations. And if you remember, when we built our tree class, we essentially defined our animations as data inside of our tree defs table. And so for our Yeti, what we're going to do is we're going to do the same thing, and we're just going to scale up or add data to this file. So I'm just going to copy the tree, and I'm going to replace tree pointers with Yeti pointers. And then I'll just add the Yeti animations. Just like this. So you see it's just a bunch of copy pasting. Boom. And what we're doing here, right, is we're just updating our data to represent a Yeti. So now in this table, we'll have our tree data, or essentially how we define a tree, and then we'll have how we define a Yeti. And that's important because inside of our tree defs here, when we call the texture Yeti, we'll be able to get that data. Perfect. So now if I go back to main, what I can do now is I can actually create a Yeti object. So I'm actually going to remove all of this Yeti code because we're no longer going to be creating our Yeti through main. We're going to essentially create a Yeti object. So I'm going to call it Yeti character. And we're going to just essentially initialize a Yeti object by calling the Yeti class, passing input. And then we just need to create and change our Yeti animations. So let me do that really quick. Similar to what we did with the trees. Oops. With the tree animations. Up. And then we have 3 animations for our Yeti. So let's just do that. Idle Yeti. And then running Yeti. And finally eating Yeti. Just like that. And so now we've essentially created a Yeti object. We can refer to our Yeti functions directly from that object. So if we go to update, instead of updating the Yeti anim, what we had before, now we're going to essentially update our Yeti character. I actually need to move all of the Yeti movement code to our Yeti class. So let me do that right away. So if I bring this into our Yeti update function, because we need to essentially manage our Yeti movement, what we need to do is essentially update all of these calls where we're updating the state of the Yeti or managing the state of the Yeti and managing the animation of the Yeti. We need to refer to the parameters of the Yeti object. So instead of Yeti state, it's going to be self.state. And instead of Yeti animation, it's going to be, we're going to call our change animation function. So just like this, we're going to do self : change animation, and then we're going to change it to idle Yeti in this case. And if we're moving our Yeti up and down or left and right, it's going to be updated to running Yeti, just like this. And then we're going to update that in all of our if statements. Finally, we have this left direction. So we essentially had a direction. So our Yeti can point left or point right, depending on if it's moving left or right. We're going to create a self.direction parameter that's going to define our Yeti object. And what we're going to do is if it's right, then it's going to be true. And if it's left, then it's going to be false. And so if we're creating a self.direction, we essentially need to make sure that the Yeti is initialized with a value for its direction. And then what we need to do, I'm actually going to remove the eating state because we'll need to create something separate. What we'll need to do is, because the Yeti is moving, we need to update its body velocity. And so the Yeti body is now the object's body, so we just have to do self.body. Now that the body is being updated, we essentially need to update the x and y values of the Yeti object. So to do that, we just do self.x, and then we call the body, and then we get the x value and the y value from the body. So just here, what we're doing is we're just updating our x and y values. And finally, we need to set the direction in which to draw the Yeti. And the direction is either pointing to the left or to the right. So we're essentially changing the x coordinate, or not coordinate, the x scale. So if x scale is negative, then the image will point to the left, positive to the right. So essentially, if the direction is true, right, and we've initialized it to true, then what we want to make is we want to make self.scale x equal to its value that we were recording in the data in our tree defs data file. So I'm going to bring that down here. And then if it's not true, right, if the Yeti is pointed to the right, to the left, we want to make it negative, that value that's in our data file. And so now we've got our Yeti who's able to move around on the map and will point in the left or right direction. Perfect. So another piece here, right here, we were managing whether or not the Yeti was going into state 2 or staying in state 1, and we were doing that because essentially if the Yeti was colliding with a skier and was eating that skier, the Yeti was destroying the skier. But in order to define that the Yeti is eating the skier and destroying the skier, we had to move the Yeti into state 2. And so what we were doing here, essentially, we need to set the Yeti to state 2. So we're going to do a Yeti character dot state 2. And then the problem is we've removed the code that essentially was triggering our Yeti eating animation. So what we need to do is we need to go back into our Yeti class and create code here that essentially is going to trigger the eating animation. And so what we're going to do is we're going to do similar to what we did with the tree, but instead of the tree removal function, let me pull that up here, the tree removal function, we're essentially going to do something similar for our Yeti, but instead of being instead of being tree removal, it's going to be Yeti eating. So let's define a new function. Let's call it eating function. It's not confusing as to what it is. And essentially, this function, right? If our Yeti is in state 2, right? If our Yeti object is in state 2, then what we want to do, oops, I forgot the then. We want to lock the movement. So first we're going to set vector x to 0 and vector y to 0, just like that. And what we want to do, right, is we want to run the eating animation. So we're going to change the animation to eating Yeti. And the thing is, we want this to run for 1.2 seconds, so essentially the whole animation can run. And so we're going to use our timer function similar to what we did with our tree, but instead of running every, we're just going to run essentially after 1.2 seconds, essentially the animation's run, we want to kick back to state 1. So after 1.2 seconds, we want to run the function where we essentially reset the Yeti state to 1, just like that. Perfect. And so now that we have this function, right, this is essentially going to be running our Yeti animation, the eating animation. We want to call that after we change our Yeti character state to 2. So we're going to do Yeti character, and then we're going to call the eating function, just like that. And so now if we kind of keep going down, what we can do is, let me actually clean all of this up. Instead of drawing the Yeti directly in main, we're essentially just going to call the Yeti character render function, similar to what we did with our trees, just like that. And so with all of these changes, now if I run the game, we have a error. Oh, you know what? I think I created the Yeti class and I forgot to source it inside of our dependency file. So let me just do that really quick. There we go. Oop. Oh, we still have a Yeti body reference. Let's see. It was line 75. So yeah, like this is one of the things that you want to do. You want to make sure all of your old Yeti references are gone. If not, you're going to get bugs because we're not initializing those values anymore. Okay, now I have it black and white. I think I deleted too much. I need to call the love.graphic reset right here. Oop. So now we have our Yeti, and the game doesn't look at all different from before. The only difference really is that our Yeti is now a class object, but you can see like you'll still pick up the skier and still eat the skier, and you'll still have kind of like this issue where if you collide with the first one and the animation's running, the second one will just disappear. So the positive thing is essentially we've moved all of the Yeti code out of main, and it's in its own class, so it's much more scalable. But we haven't fixed our or our skier situation. And essentially we're going to fix that when we create our skier class. But before I create a skier class, one of the things I kind of want to pull our attention to is you can see like our tree and Yeti actually share a lot of the similar functions. They have essentially like the same parameters except for direction, and they have the same create, change animation, update, and then render functions. And so because there's so much overlap between these two classes, this kind of means that we could probably abstract out those methods and variables. And what we can do is we can essentially play on class inheritance features, where essentially we create a parent class and then we create functions that are shared amongst children classes. And in this case, the children classes would be Yeti and Tree, and they would inherit from a parent class, which we could probably call an entity. They would inherit these create, change animation, inherit like this call to update the animation and to draw our sprite. So let's do that. So I'm going to create a new script. I'm going to call it entity.lua. And what I'm going to do, I'm going to copy paste our tree class once again. And this time I'm going to update it to call it entity. So I'm going to replace the word tree everywhere. So removal again is a tree specific function, so we don't want to keep that in entity. And so now what we want to do is we want to identify what are the variables when we initialize our entity class, which are the variables that are shared. And so an easy way to do that is you kind of look at your functions here and you see what you need. So we need like our animations, our current animation, and then we need all of our draw variables like atlas, texture, x, y, etc., etc. And so essentially what we don't need is our timer, state, fixture, body, shape, etc., etc. So I'm going to remove those. The other thing is the texture is actually a parameter that's passed through from our child class. So the tree will pass in the texture tree, the Yeti will pass in the texture Yeti. So this is actually going to be an input into our entity class. So I'm going to call it input.texture. Similar to our x and y. Our x and y is actually defined by the child class because the Yeti or the trees have different x and y's. So we're going to call the input file input parameter as well. Just like that. And let's make it y. And so now that we have these as inputs, essentially what we need to do is we need to make sure that we call this class, or we make this class inherited in our children class. So if we go to our tree class, to inherit the class, first we need to change our class call here and add the includes parameter, and then pass in the name of the class that we're inheriting. So now what we've done here is we've said tree is going to inherit all of the functions and variables from entity. And an entity, right, all of these parameters are essentially defined inside of the class, so we can delete them. The texture, we can also delete it. And then I had commented out this code, which essentially is where we initialize our entity object. And then these are the parameters that are needed. So if we go back to entity, anywhere you see the key input, actually we don't need the world. Anywhere you see the input is a variable that needs to come from our child class tree, and you'll find them in here. So just a quick summary on this. When we initialize our tree, it's going to have all of these values, and it's going to have an entity object assigned to it. And so that means that essentially anything that exists in the entity class is referable in that tree object. So we no longer need our create and change animation in our tree class, and then we no longer need to call the animation update function inside our tree class. Essentially what we're going to call is our entity update function. And to do that, we need to pass in the self argument because entity is going to refer to itself. Since animation is also no longer part of the tree, we essentially need to call it from entity. So we call entity, and once again we need the self statement. And then finally, we don't need the draw function. We can just call the entity render function or method. So just like this. And so we've done this for tree. Essentially what we need to do now is we just need to do the same thing for our Yeti. So let me save this class. And so in Yeti, we essentially don't need these functions. We don't need any of these anymore. We can uncomment these two lines. And then finally, we need to make sure that we pass in includes. And so let's do entity here. And then what we need to do is we need to update everywhere we see the self-change animation. We need to change it to entity animation because it was referring to the entity class that it's inheriting. And so we have to do that a couple times. I think 5 more times in here. So let's do that. Boom, boom. One more. Perfect. And then we don't need to call the update animation in here anymore because it exists in entity. So we'll call the update function from entity, pass in the delta time. And finally, we'll call the entity render function, entity dot render self, just like that. So now that we've created an entity object or class, we want to make sure that we source it inside of our dependencies file. If not, it's not going to work. It won't be able to refer to our entity objects. And this is actually pretty important. If you put the sourcing of entity after its child or children classes, it's not going to work. You have to make sure that entity or your parent class is being sourced before its children classes. So now if I go back to main, well, actually we can probably just render it. And I have an error here. All right. Let's see. I believe, wait, what's the bug? Entity line 23, attempt to index a nil value. Okay, so in line 23, when we're trying to essentially add an animation object, it's not finding either our frame or our interval. Did I pass in? Oh, you know what? For our Yeti class here, the texture is tree, so we need to make sure this is a Yeti texture. Okay, this should work. Perfect. And so normally everything is going to run the same as it did before because all we did was just kind of move functions around. But yeah, so essentially what we've done is we made the code a little bit more efficient, right? We've deduplicated code, so we've made everything a little bit more streamlined. So now the final class that we're going to create is our skier class, and then we'll have moved all of our game objects into classes. The skier class is going to be really easy. We're going to copy paste the tree class a third time. We're going to rename this to skier, just like this. Boom, boom, boom. Oh, well, we don't need the removal function, so I'm going to remove that. Make sure the texture points to skier. Make sure to set the user data to skier. And the only thing is our skier, right, moves left to right, so we need to update the body velocity. So I'm going to call body set linear velocity. There's a skier move variable, so I'm going to essentially move the skier by skier move along the x-axis and 0 by the y, so it moves left to right. We'll make the skier box 25 by 25. Oops, that's too big. And then we want the skier to spawn at x equals 0, so on the far left side of the screen. Another thing that we're going to do is we're actually going to create an animation for our skier. I know we haven't had an animation, it's just been like an image that's moving left to right, but we actually have 3 frames for our skier. So if we actually go to our dependencies, you'll see in our skier texture, we actually have 3 different frames, and we're going to call them. So we're going to call it skiing skier, and it'll be frames 1, 2, and 3. And so now our skier is going to have an animation, which is pretty cool. So yeah, we've essentially set up our skier class. That was super easy, right? So now what we do in main, let's bring our skier in our game. So this is where we used to create our skier when we press the space bar. We're actually going to delete all of that. And instead of calling, creating a skier, putting him in a table, and then creating a body and all of that stuff, we're going to create a skier object. So we're going to call skier character, just like that. And then, well, we actually need, let me just do this. Skier character is going to be equal to a skier object. So it takes the input. We're going to create its animation to skiing skier. And then we're going to change its animation to skiing skier. And the thing is, like, there could be multiple skiers on our screen, so we still need to put our skier object inside of a table. So we're going to call table.insert. And then we're going to put in skier table. And then we're going to put our skier character in here. And so similar, because now we have skier objects and they have animations, we're essentially going to need to do the same thing that we did with our trees, where we run an update function on the object. So we're going to call skier, and then call update on it, and then it's just skier table, just like that. We'll need to do the same thing in the draw, so let me just skip to that real quick. So skier, we'll remove the draw function because it's part of our class now, and we'll just call the render function. So for a skier collision, essentially our skier we no longer need a destroy table for our skiers or contact bodies for our skier. Essentially we just track what the skier object that's colliding with the Yeti object, what state it's in. So if the skier is in state 1, it's moving to the left, or it's moving to the right, and if it hits 2, if it changes to state 2, that means it's collided with the Yeti. And if it's collided with the Yeti, that means that the skier can be destroyed if the player presses the return key. So for that, what we're going to do is we're going to loop through all of our skiers. So for skier in pairs of skier table. So essentially we're going to get through all of our skiers. What we want to do is if the skier state is equal to 2, right, it's collided with the Yeti, then also if the player is pressing the return key, so is down return, then what we want to do is we want to trigger the eating animation and destroy the skier. The thing is, essentially, our Yeti, if he's in the process of eating a skier, we don't want the Yeti to be able to eat a second skier. We want the Yeti to only be able to eat one skier at a time. And so essentially, if the Yeti is in state 2, which is eating the skier, we don't want to be able to eat another skier. So while the Yeti character is in state 1, then what we're going to do is we're going to remove the skier from the table. From a skier table. Underscore table I. And then what we're going to do is we're also going to destroy the skier body. So we're going to do skier dot body, and then we're going to call the destroy function on it. The next thing we're going to do is, because now we need our Yeti to go into state 2 so that we can run our eating animation, we're going to essentially and we also want to score a point, we're going to move these 3 lines of code down here into here. And that's the logic for triggering our eating animation for our skier. And don't want end. There we go. And we're going to delete all of this. And so what we need to do, right, is we need a way to kick our skier into state 2. And so if we go to our collision detection code in begin contact and end contact, essentially what we can do is we can reuse the code that we use for our trees to identify which tree is colliding with the Yeti. Instead of a tree now, though, we'll use our skier. And then if the skier collides with the Yeti, then we change it to state 2. So that's how we can do that efficiently. And then just need to call the skier fixture. And essentially, if the Yeti doesn't eat, so if essentially the player doesn't press the return key after a collision, we're going to kick our skier back into, we're going to kick our skier back into state 1, like here, just like this. Perfect. And so now we should have our skiers, who are individual objects now. Oh, I skipped a step. I need to add a call or source our skier class. Just like that. This is one of the things I always kind of forget. But there we go. Oh, what is going on here? Oh, you know what? Another thing. Our skier is supposed to move, but we're not updating the X and Y values of our skiers. So let me go to the Yeti object and bring in the self Y, self X update. There we go. Did I not save it? Okay. Let me see. Self.x, self.y. Oh, it's static. I need to make it dynamic. There we go. Perfect. The body was static. And so here's our skiers. And now if the Yeti's, if you press the return key, nothing's happening. What the heck did I do? Try again. Well, it's colliding with the skiers, but it's not triggering the eating animation. So let's see. So our skier goes into state 2 when the collision happens. And then get body, skier body. Yep, that looks good. So in our skier table, if the skier is in state 2 when you press the return key, while the Yeti character is in state 1, I forgot the call to the state. There we go. All right. And so now, boom, our Yeti is eating one skier at a time. And destroying that tree and eating that skier. Cool. So yeah, we were able to implement object-oriented programming for all of our game objects, which are our skiers, Yeti, and trees in this video. And so what we've done is actually kind of set a framework that is going to allow us to really scale this game up. Like if we want to add another game object, like let's say we look at our sprite sheet and we want to add this dog or the snowboarder, we can just use our class, like create a snowboarder class or maybe use our skier class, but use a variant snowboarder. And we can just scale, and we don't really need to write new code unless we want to create a new function. So that's really cool, and it's going to allow us to really scale our game, add more components to it, and kind of make it a much more fun experience. So I think like in the next video, we'll probably add some new characters. And yeah, as always, thanks so much for watching. Hopefully this was interesting video, and I'm super happy to have you along with this game development learning journey. And please like, comment, subscribe. Let me know what you think. All right, all the best. Thanks.